Today we're going to look at calculating quartiles of a data set. We've already met one of the quartiles before, which is the median, and we should already know how to find the median of a data set. As a quick reminder, the median is the value that splits a distribution of ordered numbers into two equal parts. So to give you a couple of examples of this, we have two data sets here. This first data set, the numbers are already in order, which is important. Remember, the median must be the value that splits a distribution of ordered numbers into two equal parts, so numbers in numerical order. And basically what we're looking for the median is the middle value within that set. So the middle value here is 3. And what it does is it splits the data into two equal parts. It basically splits the data in half. So the median here is 3. For the second data set over here, it's not quite as simple because we have an even number of values, which means there's no one value in the middle here. So if I look at this, there are really two values here in the middle, neither of which is the median. The median is the value that, as we said, splits the data into two equal parts. So we need one single value, which has to be halfway between 10 and 12 here. So the median in this case is equal to 11, halfway between the 10 and the 12. And again, what that does is it splits the data into two equal parts. Now we've reminded ourselves about median, we can go back and look at quartiles. While the median is a single value that splits a data set into two equal parts, the quartiles are basically three values that split a data set into four equal parts. Now, just to kind of illustrate this in a very basic way, if you imagine a data set here, we have our median, which if we look up here, median we call Q2 or quartile 2. So we can write that down here. That's our median value, splitting the data set into two parts. And then we also have the lower half of that data, again split into two, and the upper half of that data split into two. So what happens is we end up with four equal parts here. 1, 2, 3, 4 parts to our data set, and they are split by the three lines here, which are our quartiles, Q1, which is the lower quartile, Q2, which is the median, and Q3, which is the upper quartile. In the next slide, we're going to show you a method we can use to actually split the data into four equal parts and then identify the values of the three quartiles. Remember, the quartiles are three values that split the data into four equal sections. What we want to have is we want to have our data in four chunks. Okay, when we divide something by 4, or not divide a value by 4, there are four possible remainders we can end up with. So we can end up with a remainder of 0, 1, 2, or 3. Obviously we can't have a remainder of 4 when we're dividing by 4. So what we're going to use is a method using boxes and circles. The boxes will represent the four equal parts we split our data into, and any circles we draw in here will represent any remaining values and where we position them. So in an example where there's a remainder of 0, say for instance we have 20 pieces of data, when we divide that by 4, that comes to 5 remainder 0. It means we'd have 5 pieces of data in each box, and because there's no remainder, there'll be no circle to place in here. If we have a remainder of 1, for instance, say for instance we have 21, so when we take that 21 and we divide it into the four equal parts, well 21 divided by 4 is 5 remainder 1, which means we'd have 5 pieces of data in each box, but we'd have this 1 left over. Now what we need to do with the remainders is we need to distribute them evenly so we have symmetry. So if I only have one remainder, then where I'm wanting to put that is right in the middle here. So what I'd end up with then is I would end up with 5 pieces of data, 5 pieces of data, 5 pieces of data, 5 pieces of data, but the one that was left over would go in the middle here. If I have a remainder of 2, for instance we have 22 numbers in our data set, when I take 22 and I divide it by 4, I get 5 remainder 2, so I put 5 pieces of data in each of the boxes, but I would have 2 numbers left over, or 2 values left over. Again, these need to be distributed symmetrically. So the 2 values, I would place 1 in here and 1 in here. So we have that idea of symmetry down the centre. And for the last one, a remainder of 3, let's take for instance 23 pieces of data in a data set. When I divide that into 4, I end up with 5 remainder 3. So 5 remainder 3 again, that would mean I would have 5 pieces of data in each box, but I would have 3 numbers left over that didn't fit into boxes, so need to be distributed symmetrically. So I put 1 in each of those spaces. Now where we're going to find the quartiles when we go on to do this in a practical example next, and hopefully it'll make more sense when you see it in a practical example next, is the quartiles are these gaps here. Okay, are 3 quartiles, 1, 2, 3, and 1, 2, 3. So what's really important here is basically you kind of memorise this pattern here. If there's a remainder of 0, no circles anywhere, a remainder of 1, a single circle in the middle of your 4 boxes, a remainder of 2, 1 here and 1 here, and a remainder of 3, you put 1 remainder here, 1 remainder here, and 1 remainder here. Because these are quartiles, there will always be this idea of trying to split them into 4 equal parts. So your diagram or working that you use will always have 4 boxes. So we'll now move on to finding quartiles for some real data sets. We'll have a look at the step-by-step method to use and show you how to do each one. So let's have a look at our first data set here. We've got these numbers here. Now remember, when we're finding the median or when we're finding quartiles, we must have an ordered data set. So step 1 here will be to order the data. So let's put these numbers here in order. Let's see, that's going to be 23, 25, 26, 28, 35, 35, 45 and 45. So basically I've renumbered those, reordered those in numerical order. The next thing is to look at how many pieces of data are actually in that set. So we have 1, 2, 3, 4, 5, 6, 7, 8 pieces of data there. And remember, I want to split that into 4 equal sections. Now, if you think about it this way, we've got the number 8 here, 8 pieces of data. I want to split that into 4, which is 2, remainder 0. What that means is I have 2 numbers in each box and no remainder, so no circles. So what I'm trying to do then is I'm trying to get my data split, so I have 2 numbers in each box. Remember, it's quartiles, so I'm going to have 4 boxes and start to put 2 numbers in each box. So 2 numbers in the first box, 2 numbers in the second box, 2 numbers in the third box, 2 numbers in the fourth box. Now remember, the quartiles are the values that split the data into 4. So my quartiles will be found in this gap here, in this gap here, and in this gap here. So what I can do is just put arrows down from each of those gaps and write down my 3 quartiles. Now Q1, the lower quartile, is the value which is going to be halfway between 25 and 26, and therefore Q1 is going to be 25.5. Quartile 2, a little bit harder to work out this one, so I've got 28 and 35 here. I need the number halfway between 28 and 35. Now, that's quite tricky, so a good way to do that is to add those 2 numbers together and then half your answer. So for instance, at the side here, we can do 28 plus 35, all divided by 2, which is equal to, let's see, 63 over 2, which is going to be, let's see, quartile 2 over here. We'll put quartile 2, 63 divided by 2 is 31.5. And then a little bit easier for this last one, we can probably do this by inspection. Halfway between 35 and 45 will be 40. So my upper quartile, Q3, is equal to 40. So what we have there, if you look at it, we have our data split into 4 equal parts represented in the 4 boxes. And these gaps here represent our quartiles, in other words, the values that split that set of data into the 4 equal parts. Let's have a look at example B here. Again, we have numbers, but they're not in numerical order. So let's first of all stick them in numerical order. So we're going to have, let's see, 2, 2, 3, 4, 4, 5, 5, 6, and 9. And what we'll quickly do is we'll just check how many values we have there. So counting them up quickly, 1, 2, 3, 4, 5, 6, 7, 8, 9 values. So we've already ordered the data. We're now going to take that 9 and divide it into 4 equal chunks. So 4 into 9 goes twice, but this time we have a remainder of 1. So that means I'm going to have 2 numbers in each box and 1 circle. Now if you remember the patterns we looked at on the previous slide, that is going to look something like this. So that one remainder is going to go in the middle to make it symmetrical. So let's try and put that around our numbers over here. So 2 numbers in each box and 1 circle. So let's see, 2 numbers in the first box, 2 numbers in the second box, 1 circle, 2 numbers in the next box and 2 numbers in the next box. So our data is split into our kind of 4 equal parts. So 1, 2, 3, 4, but we obviously have one remainder which is going to go bang in the middle here. So let's start taking our quartiles from that. So again, the gaps between the boxes are where we're going to find our quartiles. So Q1, Q2 and Q3. Now let's have a look at this first one. Q1 is halfway between this 2 and this 3, so that's going to be nice and easy, 2.5. Quartile 2, well actually between this box and this box there is just a single value, so when there's a circle there it's much easier, we can just write that number down. 4 is the value right in the middle of those two boxes, and for the last one here what we have is a number halfway between 5 and 6 we're looking for, which is going to be 5.5 or 5.5, and that then gives us our 3 quartiles. We'll now look at example C, and remember the first step here is to take this unordered set and put it into numerical order. So we'll quickly do that here. That's going to be, let's see, 3, 4, 4, 4, 5, 5, 5, 5, 6, 8, 8, 10, 14 and 16. So we'll just do a little check here. We started off with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. So just check I've got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's fine. It's worthwhile doing that check. If you've got a lot of data and you're trying to sort it into order, just do a quick count and check that you've got all the pieces of data there at the end. Now, because I have 14 pieces of data, I'm going to take that 14. And I'm trying to remember with quartiles, we're trying to split the data into 4 equal sections. So we're going to divide that by 4, which is going to give us 3 remainder 2, which means I'm going to have 3 numbers in each box. And 2 circles left over. And if you remember the pattern from the previous page, remember we're always going to have these 4 boxes, because that's the whole idea of quartiles, to split the data into 4 equal parts, and those 2 remainders, those 2 circles are going to have to go in so this is a symmetrical pattern down the centre, so I'm going to put 1 at one side and 1 at the other. So all I've got to do now is recreate that pattern around my numbers over here. So 3 numbers in each box and 2 circles following this kind of general pattern over here. So 3 numbers in the first box, 1 circle for my remainder, 3 numbers in the next box, 3 numbers in the box after that, 1 remainder, and 3 numbers in the last box. And remember, what I should have at the end of here is I should have my 4 boxes always, and then it's a case of where do my remainder of 2 go, where do my 2 numbers which are left over go. And it's again following these patterns we looked at in the other page. So remember, the quartiles are the values that split those 4 boxes. So the quartiles are here. Quartile 1 is nice and easy, that's just 4. Quartile 2, well, quartile 2 is sometimes confusing. So quartile 2 here, we've got a 5 and a 5. The number halfway between 5 and 5, well, we're just going to consider that to be 5 itself. And then what we've got here is the last part, which we've got the number or value which splits this box and this box, which is 8. So quartile 3 is 8. So here we have our 3 quartiles. Our lower quartile Q1 is 4, our median Q2 is 5, and our upper quartile is 8. We'll now go on and look at example D in the same way. The first thing we're going to do here is we're going to put these numbers here into numerical order. So let's do that quickly. We're going to have, let's see, 2, 3, 4, 5, 6, 8, 9, 9, 11, 12 and 13. Now again, a quick check, I've got all my numbers here. So let's see, I started with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I still have 11 values, so that's fine. I now need to find a way of splitting those 11 values into my 4 equal boxes. So I'm going to take that 11 over at the side here and I'm going to divide it by 4. Now 4 goes into 11 as we know twice, which makes 8, which means I have a remainder of 3. Now the 2 there at the top means there's going to be 2 numbers in each box. And the remainder of 3 means we're going to have 3 circles. Okay, each of those remainders will go in a circle. So what we're trying to do is again recreate that kind of idea, that pattern of how if I always have my 4 boxes and I want to put the remainders in there so it's nice and symmetrical, I've got 3 circles to fit within these gaps. So 1, 2, 3 keeps that nice and symmetrical. And again, it's just a case of learning those patterns and making sure you can recreate them. So having a look at that now, what I need to do is put 2 numbers in each box. And then in each of the circles there'll be 1 number basically. So and this is the kind of pattern I'm following, and these are the patterns we said we need to learn from the other page. So let's go through that. 2 numbers in each box. So let's do 2 numbers in this box, and then we have a circle. 2 numbers in this box, then a circle. 2 numbers in this box, a circle, and 2 numbers in this box. And what we're trying to do, if you compare that, this is the pattern we're trying to create. 2 numbers go in each box and 1 circle between each box, in this case for a remainder of 3. This one's nice and easy to pick the quartiles from. Remember, the quartiles are the values which go between these boxes, so they are actually all circled in this case. So we can write down our lower quartile Q1 is just 4, our median Q2 is just 8, and our upper quartile Q3 is just 11. So as you're doing these questions, the kind of important thing to remember here is every time you do this, you should always have 4 boxes. When you do the division, that first number here tells you how many numbers go into each box, and the remainder will tell you how many circles you need to fit in there. And we've looked at the patterns, as I said before. We need to make sure we know those kind of patterns. What's the pattern look like for a remainder of 0, a remainder of 1, a remainder of 2, and a remainder of 3. And then it's just a case of kind of recreating that over here.